Let's start by writing the formula equation for this reaction between potassium chromate and barium nitrate in aqueous solution. Potassium is K, chromate is CrO4, and the charges on these ions, potassium being in group 1 is going to lose one valence electron to become a 1 positive cation, and chromate is a polyatomic anion with a 2 negative charge. You can crisscross these numbers to get the ratios of how they combine. So the formula unit for potassium chromate is K2CrO4. And that's going to react with barium nitrate. Barium is Ba, nitrate is a polyatomic anion, NO3, with a 1 negative charge. Barium, being in group 2, is going to lose 2 valence electrons and will form a 2 positive cation. Again, you can crisscross these numbers to find the ratios of these ions in compound. Now, you need a parenthesis around the nitrate because there's 2 of them. Now, this is a double displacement or double replacement reaction. It's a type of double displacement reaction known as a precipitation reaction. The formation of a precipitate is what's going to cause this reaction to occur. So to find the products, you can just switch the cations in these compounds. I might run out of room, so I'm going to just continue on the line below here. So potassium, let's rewrite that with nitrate. And because the charges are the same, they're going to form in a 1-to-1 ratio. So there's your formula for potassium nitrate. All nitrates, as well as all alkali metal in compounds, are going to be soluble. So we put AQ there. Now the other compound is going to be barium combining with the chromate anion. And because the charges are also equal in magnitude, they're going to cancel each other out and reduce to 1-to-1. So that's also your formula for barium chromate. Let's take a look at our solubility rules. Notice that chromates are generally insoluble. Therefore, barium chromate is going to be the precipitate. Now let's balance this equation. There are 2 potassiums on the reactant side, so let's put a coefficient of 2 in front of potassium nitrate. That's also going to balance the nitrates out. So there's your balance equation. Now, in aqueous solution, this formula equation doesn't truly show what's going on. These compounds are not stuck together, roaming around the beaker of water or whatever the container they're in. Rather, they're going to dissociate. And the way you know which ones dissociate are going to be the strong electrolytes. So next what we need to do is determine the strong electrolytes. Those are the ionic compounds that are going to dissociate completely in water, which are going to be all of these. So all these compounds we need to separate into their ions. We call that a complete ionic equation, where we separate all the compounds that are strong electrolytes into their ion forms. Alright, so let's rewrite potassium chromate dissociated into its ions. I'm going to bring this 2 up here so it doesn't look like a diatomic molecule. We need charges on ions, and these are all dissociated in water, so we'll put AQ for each of these ones that dissociate completely. I'm going to write the products on the line below because I'm running out of space. Now the precipitate does not dissolve, so it doesn't dissociate. It's insoluble. So we're going to write that just the way it is. It doesn't get charges. And we indicate the precipitate with the S in parentheses. So the next step is to eliminate the spectators. So the ions that appear unchanged before and after the reactions is the nitrate and the potassium ions. So we need to get rid of them and rewrite what's left as the net ionic equation. Your final answer should be balanced in terms of charge So on the reactant side, the charges cancel out, and there's no charge on the product side. The mass should also be conserved, as well as the charges. So this is already balanced. Now, this is an opportunity to check your work, and if things are not balanced or have gotten unbalanced in an earlier step, you can balance it here. So the net ionic equation only shows the components directly involved in the reaction.